Hello everyone, myself Rajeev Singh, Narana Physics faculty. So once again we are going to start our online classes. Due to some network issue right now I am in the totally rural area where I am not getting the complete internet to start the class on the board, or you can say with the help of laptop. So on the highly demand or request of my many students, right now I'm going to start on the paperwork. So see, first of all we have to discuss electric flux, but to understand clearly what is electric flux, how calculate electric flux, we need to understand concept of area vector. So I just wrote here, see, concept of area vector. So here definition I have wrote, you have to read, any line perpendicular to the plane is called area vector. So from here you can calculate some points like that. Any line perpendicular, okay, so this must be perpendicular, right? And then it is called area vector, and third, this is for plane. It means area vector is a perpendicular line, and that must be defined only for plane, right? It means you cannot find for a line. Area vector you cannot find for a line. Always you have to calculate for a plane like xy plane, like yz plane, like zx plane. Okay. On the basis of area vector, surface are classified into two categories. First is open surface and second is closed surface. Again I am reminding you, these are the building block to complete view, complete knowledge of electric flux. When you get the information of area vector, then I think every problem which is related to electric flux you can do it very easily and definitely with good efficiency, right? So surface divided in two parts, open surface and closed surface. The thing is that what is the open surface? I wrote here definition, you have to read what? Those surfaces which can be touched from both sides, like a square or rectangle. Suppose this is a notebook. So in this case I can touch this page from this side as well as this side. What is the shape of this notebook page? You can say shape of this notebook page is what? A rectangle. So rectangle is one kind of open surface. A square is also, ring is also, disc is also. These all are open surface, right? So open surface here, what? How you can calculate area vector of open surface? I wrote here, area vector of open surface is always perpendicular line. So suppose that this is a open surface, so it's one line may be perpendicular like upward and another line may be perpendicular towards downward. So which one you have to select? So in this case you have to freedom, you can select any one. Suppose that I assume this is a one rectangle in xy plane, right? This is a rectangle in xy plane. So it perpendicular may be in positive z direction or may be in negative z direction. So anyone can say its area vector is along k cap or minus k cap. Both are correct. But you have to consider one point, you have to keep one point in your mind. Suppose that you have select this one, positive k cap. It means throughout the problem you have to maintain this one only. According to your convenience, you cannot select sometimes k cap, sometimes minus k cap. No. You have a choice, select either k or minus k. But throughout the problem you have to stick. Suppose I select k cap. So throughout the problem I have to stick with only k cap. I cannot go through minus k cap. Suppose one of my friend select minus k cap. So he has to go through minus k cap, not k cap, right? So just I wrote the statement here. Once you select area vector, should we continue throughout the problem? Now coming on the closed surface. Closed surface means those surfaces which cannot be touched from both sides, like a sphere, hollow sphere as well as solid sphere. You can touch either from inside or either from outside. You cannot touch from both sides, like cube, cuboid, you cannot touch from both sides. So I wrote here cube, square, sphere, these all are closed surface. So in the closed surface there are lot of faces. See, this is the one face. So in case of closed surface you don't have choice. In this case only outward perpendicular line will be area vector. Just suppose this is the x-axis, this is the y-axis, this is the z-axis. If I am talking about this plane, so this is what y and z, so this is a yz plane, right? So its area vector according to your previous concept may be positive x or may be negative x, but right now you have to only choice to select negative x because this will be outside. If you select positive x, this will be inside, which is not valid. So in the case of closed surface, always you have to take area vector outside. Done, buddy? Okay, thank you. Yeah, so once again we are here problem based on area vector. So just start with simple problem. Suppose that we have a square in the xy plane, right? One corner of a square at the origin 0, 0, another corner here 20, 0, another here 0, 20, and this is 20, 20. Here it is given that x is in centimeter, y is in centimeter. They are asking find the area vector. So simple, there is a two method to find area vector. I will explain one by one. And just see first method. Right. So first method, what will be this vector? You can say this vector, suppose that this is a vector, vector A. So vector A will be 20 I cap because it is along the x direction. Suppose this is a B vector, vector B. So vector B will be 20 j cap. So we know that product of this one will be area. So basically area vector will be, just make this one a small b for sake of convenience. So this will be a small a cross a small b. Yeah, same, anybody can write like that, b cross a. It is not specified only a cross b or b cross a, we can write anything. So this will become 400 because 20 into 20, 400 I to j it means k cap. If you solve in this case, so we will get 400 I to j, it means minus k cap. So simply I have already said you, whenever area in xy plane, its area vector always will be, it is open, so k cap or minus k cap, so both are valid. Done, buddy? So such kind of elementary problem will associate in the case of electric flux. Okay, so see the next question. Just see here a square, which side is 5 centimeter. Here is square, which side is what? 5 centimeter. This square is kept in such a way in XYZ plane so that its some sides are in XY plane, just like this is Y, this is X. So this side will be in XY plane, and this is XZ plane, so this side will be in XZ plane, right? They're asking find area vector. So whenever you are going to find area vectors, always you have to take cross multiply or vector product of any two sides, right? So you can write this is also 5 centimeter. Yeah, this is also 5 centimeter. This is also 5 centimeter, right? Okay, so what we can write, suppose that this is a small vector A and this is a small vector B. So a small vector A, I can write here 5 j cap. Okay, now a small vector B, so you know a small vector B is like that. This is a x plane, sorry, x axis, and suppose this is Z, so I just making like that for sake of convenience. This is a Z. So this vector B is at, just see here, vector B is here at 37 degree. Vector B is also 5 centimeter. So we can resolve this one. This side become 5 cos 37 and this side become 5 sine 37. So we know that 5 into 4 by 5, this get cancelled, so this become 4. We know that this become 5 into 3 by 5, this get cancelled, so this become 3. It means we can write here vector B is equal to 4i cap plus 3k cap. Why? Because this is a z-axis. So here you got it, vector A and vector B. Now to find its area vector, you have to take its cross product. So vector area vector is equal to vector A cross vector B. So A is equal to, we know that 5j cap cross B. B is equal to 4i cap plus 3k cap. You can reverse means you can change the position. You can write 4i cap plus 3k cap cross 5j cap. So see, 5 4s are 20, 5 4s are 20, or j to I. So j to I, we know that this become minus k cap. If you don't have idea how to take cross product, then you can comment. I will make a paper video again telling you. Here no network available, so I cannot promise to give you board video and laptop video. I have laptop, I have each and